The next session will be covered by Mr. Bernardo Di Castro. He's the president at Hexagon. He's going to share his insights on end-to-end precision farming solutions for optimized efficiency. Over to you, Bernardo.
Thanks, MC. Well, first of all, thanks everyone for joining in and for NASCOM team for making the invitation. You can please start my presentation. Would like to start from a brief introduction of our company. Next one, please. So a few slides on who is Hexagon and what is the business that I'm heading here from Brazil. Hexagon is a global leader in the long history in sensoring business and more recently combining these sensors with software solutions. So the core of our vision today is exactly this fusion between the digital world provided by the software solutions and the physical world provided by the hardware itself, or these sensors that has always been a primary business from Hexagon. Next one, please. Hexagon has a global footprint. It's a company today of almost 4 billion euro in revenues. It's a strong DNA in growing through acquisitions and investing in innovation. From 10 to 12% of our sales are annually invested in innovation. And we have, next one please, we have several, applicated this in several different industries. You can see here some examples: geosystems, manufacturing intelligence, power process and marine oil industry, safety and infrastructure that leads to smart cities. And of course, agriculture. So I am the head of this operation globally of agriculture. That's what we are going to see in more details here, and what I'm going to present a few examples of what we are doing. So going to the next one, please. It's just an overview of who we are in the agriculture division of Hexagon specifically. We have our headquarters here in Brazil, where I'm based. But very wide footprint globally. We have business today in more than 36 countries. As you can see, some figures of our operations, we play in a wide range of types of crops, but a strong footprint in sugar cane, for example. As you can see, more than 46% of overall sugar cane production somehow goes through our planning system that I will show examples later. We are also leaders in solutions for forestry, cultivation in Latin America, and pioneers on that. And we have several other examples of customers using our solutions in different continents as well, including Asia. Next one, please. A few of our customers and in the main industries that we play, still talking about the agriculture division. So we provide our solutions to well-known OEMs. We have hardware solutions for those machine industries. We also provide, you may recognize some of these names, which are top producers of sugar, ethanol, pulp and paper, and also distributors, machinery distributors globally. So next one, please. And then we are actually starting the main content of my presentation, which resembles to the title of it, which is the end-to-end solutions for precision farming. And this is the core of our strategy inside Hexagon Agriculture. You see here a summary of a little bit of everything we do. which are the solutions that goes from planning and optimization tools for agricultural operations, and then it includes not only the short-term planning, like what are we going to do, what in the current season or in the next weeks in terms of applying inputs or in terms of allocating machines, but we also include solutions for long-term planning. We can support planning 5-10 years ahead in larger operations. Then once you plan, you want to execute that plan, and that goes to the second quadrant of the slide you are seeing, which then are solutions for sensoring and controlling machinery. And once you are controlling and executing, you want to monitor it in real time, and you want to see details, see analysis of those operations, which are the remaining two quadrants. So my presentation will be around this summary. I actually brought 3 or 4 examples, starting from 2 examples in the planning and optimization, and then 2 other examples that combine these other 3 quadrants: the execution, which is machine control, monitoring, and analytic and analysis, which usually in practice work very close to each other. So I'm going to show, starting then, an example of planning and optimization solutions. Next one, please. Just all the examples will come with this kind of context. So what is the problem? What is the challenge that we are trying to address? So in a harvest, sugarcane harvest season, usually you have this kind of problems. You see the sugar mill in the middle of it. There are hundreds of fields or sources for the sugarcane that has to be brought to the mill. Of course, resources are always restricted. Time is restricted, and in this case, even there are parameters that are time sensitive. That means sugarcane throughout the harvesting season, it will lose or gain potential to yield, and so the setup, the arrangement, the scheduling of these fields have to be optimized in order to optimize the final yield. So that's what we are doing. We respond to that main question: what is the optimal sequence of fields using several parameters? You can go to the next one, please. Using several parameters. In the middle of it, as you can see, is the mathematical models, like those curves I just showed in the previous slide, that is modeled in the system, and with all the restrictions and the resources available, we are able to come out with optimized plan, and so bringing benefits that I will primarily, in this case, it's the increase in yield. I will give some figures about that later. That can be, as said, from annual, monthly, or weekly, or even sporadic. The managers can simulate some scenarios and see what is best for that harvest plan. One second example, next one, please, is related to transportation. It's a common issue as well. It's you have a plant, it doesn't need to be a sugar mill, it can be like a storage facility or food and beverage industry. You always have to source from the fields, and that's the big question: where should the truck come and pick up material, or the other way around? If you are the farmer, who should I sell, or how should I transport this? So this is the question to be answered. Next one, please. And in these scenarios, you see issues like fixed plans. You see dispatching decisions that are previously made, so they don't take into account what is actually happening in the field, what is the actual status of the transportation. So that's a clear inefficiency of the process that we, with our solutions, we try to address. We can see in the next slide that, again, the mathematical models are in the center of that. We use historical databases of previous years. We use the actual resources and possibilities of those operations to use. And with that, we come out with an optimized dispatching plan. With additional solutions, we can monitor this dispatching and compare whether it's actually how it's actually taking place, and feed it back to the planning system, so the dispatching plan can be updated in real time. That's the start of what is again the title of the presentation, the end-to-end solutions, which is planning, monitoring, and feeding it back to the plan so you can optimize the whole operation. So in the next slide is just for record, and I focused the previous examples in harvesting and transportation, but it also applies to other kinds of operations like fertilization or spraying or whatever. Kind of similar problems are faced in the field that can be optimized somehow and receive these optimized plans. So in the next one, we can see some figures and the actual benefits of these solutions. These are all examples of different customers in different scenarios where we have. I gave previously the yield increase example, close to more than 1% of yield increase in the sugarcane mill in Asia we could achieve. This transport optimization system can either, well, we give the name of increased capacity because you can load more material with the same infrastructure you have, but usually customers, of course, they reduce their fleet to fix the amount of raw material they need to transport. So many other examples and benefits that these optimizations can achieve that without them, of course, with the human, depending on the human decisions, that they would not be achieved. So let's see then the second types of examples. If you recall that first slide I showed about the solutions, the second, third, and fourth quadrant of the figure, it's about executing, monitoring, and making the analysis of the operations. This is the current status that we see. You see field operations, even with these large and sophisticated machines, we see this kind of problems. The field supervision is usually dependent on samples in the field, or what's happening in the field. That brings a lot of inefficiencies, like the broken and unreliable databases, like the lack of traceability of what was executed in the field, and many others. So in the next slide, we can see then what can we do to achieve that, which combines those hardware sensoring in the machine that will make sure the inputs will be applied at certain rates, that the certain activities, operations will actually be executed as planned, and not only ensure in the field, but also bring information to show to management and to record what was done, and provide traceability, provide accuracy in stock updates, provide reliability in third-party and contractor management, and so on. So two quick examples on that in the next slide, please. This is fertilization control. We make sure the independent of the operator speed or any other environmental challenges, the controller can ensure certain rate of application and bring this information back, as you can see in the map, in very detailed and accurate data. In the second example, we can see in the next one, it's similar but applied to spraying systems with an additional solution of synchronizing machines. So if you have there are more than one machine working in the same fields, they can talk to each other and reduce overlaps. Only that, from our experience in customers, it can reduce close to 10% of the inputs applied. So all this, and then it's highlighted in the right bottom of the slide, comes with this rich data that we log in the field. That is the main outcome of this process that, as said in the beginning, that's what is going to feed back the planning loop. And we can see now in the next slide again, in more details, those quadrants of our solutions. Next one, please. Where you can see now pretty much all the products that we have in all of these areas. So the examples I gave in the last example, I was highlighting the data that we can use and feed back to those planning and optimization software. And to finish in the last one, just emphasizing our core strategy of, you may have the impression that our solutions, we know the environments in Brazil and India are quite different. Please, the next slide. In terms of arrangement, the size of the farms and so on, but would like to emphasize here that we have several examples of the same technologies applied in very, very different kinds of farms, not only in Brazil. And of course, I didn't use the word sustainability during my presentation, but would like to connect here and make sure it's clear the relation between all these benefits that our solutions can bring and sustainability. That is highlighted in this slide as reduced waste of inputs, increased yields, the improvement of land usage, and so on. So with that, I conclude, and thanks again for the invitation. Hope we have contributed to the discussion here.
Thank you, Bernardo, for your insights. And I'm sure the innovation that Hexagon is bringing is definitely going to have a huge, huge, huge impact and benefits to the agriculture sector.